Are you ready to graph? Let's graph. So you have this exercise you need to do, practice worksheet. So here's your bullets. You're going to use your knowledge of those videos. Some of those videos you might have to watch twice, rewind, do what you got to do to learn the material. That's the only thing we're doing today is that. So we want to save ourselves a lot of words and use pictures, such as a graph. So we're going to do two problems. This is what you have. If you know how to use the drawing tool on here, you can do the drawing tool. Otherwise, you can do this on your own paper, and I'll show you how. In a bit, you would do it by hand. If you're doing it by hand without graph paper, which most likely you are, then some of the rules for counting the number of squares and dividing, will not apply to you. But nonetheless, I have linked in the Google lesson this thing here. So I just want to make a little sense of this for you. If this was overwhelming and too much, I want to quickly go through this. Okay. So line graphs, which is what we're primarily interested in. So right here, we got to imagine this as a complete experiment. Okay. So this would be your data table and it would be blank, right? So this particular experiment was how many paper clips can I pick up with a magnet? What if you had several little magnets? Said 1, 2, and then 3. Well, your first common sense answer is probably one magnet might pick up 1, 2, or 3 paper clips. But of course, the larger the magnet or the more magnets you have, the more paper clips you'll be able to pick up. So it's a very simple experiment. So this is what we're going to do. We phrase it the effect of increasing coils, that's the magnets, on the number of paper clips it can pick up. Okay, so number of coils, 5, 10, 15, and 20. This would be called the independent variable, right? We are choosing to do 5, 10, 15, and 20. And we're going to try each one 3 times, okay? You never know. If you do it just one time, it might be correct, but it might not be. Remember, we want to get accurate and precise measurements. And we just had that lesson on accuracy and precision. So one way to test our accuracy and precision is to do multiple trials. And then even though no single one might be totally correct, all the numbers taken together probably represent the most correct value. So these are just scientific concepts to keep in the back of your head. Don't worry about memorizing this. Just try to understand what I'm saying. So trial 1, 2, and 3 with 5 coils resulted in the first time 3, 5, and then 4. To get an average, you simply add those 3 numbers up, 3 plus 5 plus 4, and divide by the number of trials. In this case, there's 3 trials. So that's 8, 9, 10, 11, 12. So you have 12. 12 divided by 3 is 4. And so we wrote 4. So this is the average number of paper clips, and it's probably the most accurate. Then we did it again. This time we got 10 coils. The first try we got 7, the second try we got 8, and the third try we got 6. To get the average, we added up those 3, and then we divided by 3, and we got 7, and so forth for 15 and for 20. So this is the independent variables, the number of coils, and the dependent variable, that is how many paper clips we could hold, depends on the number of coils. So you can see you manipulated the number of coils, and we measured in response to the number of coils how many paper clips it could hold, 4, 7, 11, or 14. So this is not too difficult to see that obviously the greater number of coils you have, 20, the greater number of paper clips you could pick up with the magnet. So that's what step 1 is, just identifying the variables in any experiment. And so I remind you here, independent variable, dependent variable. It's the next part that gets a little tricky and that may freak some of you out. So in order to get the range of values for what's going to be our graph, all right, we take the range of paper clips. So 14 is the largest number and 4 is the smallest number. So this is going to give you the range. The range of your data goes from 4 to 14. Doesn't have to be a 0 there. So what is 14 minus 4? That's your range, 10. And for the number of coils, your highest is 20, your lowest is 5. What's the difference? 20 minus 5 is 15. So that's what you see in step 2. Determine the range of variable. Step 3 is telling you determine the scale of the graph. This is probably the hardest, and you know what? This is the easiest part to do by trial and error, just trying to evenly space out all those dashed lines, okay? But it's very possible. I'm going to pause this and show you how. Okay, so I'm going to draw axis, and you know now this is, whoops, it's not working yet. Y-axis, x-axis. Okay, so label your axes. And how many dashed lines do you put here? Well, for example, over here we have the 10 paper clips per 36. I want to make our example a little easier. I'm going to just say 40. So let's say we had 40 lines. So 10 divided by 40, or you know what, we can even do it 50 lines, because in either case, we go here. So I punch into my calculator, 50 lines divided by, actually 10 paper clips divided by 50 lines equals 0.2, okay? So we have 0.2 paper clips per line. We're gonna round that up to 0.5, and you do the same thing with the coils. There were 15 coils up here, and you divide that by the number of lines. So you always just count the number of these lines, and again, this is gonna be the x-axis. So you count the number of lines. Now I'm adding my lines, and you have the freedom to do this. This is why it's easier actually to make your own graph than to go by possibly the grid lines. But you would just count all those squares. Here I put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and what would we do on the top? We're gonna have 0.5s, 36, and how many readings did we have? Do you remember? You gotta come over here. And we had about 1, 2, 3, 4. We had a range of values that went all the way up to 14. So again, your highest number was 14. And that's going to be in increments of what? Right here, 0.5. Okay, and that's going to be your y-axis. Right here, y-axis. So let's go ahead and put those on there best we can. Let me get my annotation tool back ready. I'll stop it. So it's going to be a lot. So up to 14 from our lowest. So in 0.5, so -1, -2, 3, 4, 5, 6. And I'm gonna have to make some extra room, right? So trial and error, go back. 6, where are we at? 0.57, 0.58, 0.59, 0.510, and it goes on up. Anyway, you're gonna get up to about 14 here. So you're gonna do this much nicer than I've just done it for you on this computer example. But your top number should be 14. Probably good to keep it at 15. And your top number here would be what? Well, do you remember what our range went up to? 20. So it would be something like 5, 10, 15, 20. But you're going to have it evenly spaced across the bottom. So in that example, I'm going to go ahead and clear all this. In our example, if we look down here, we'll see what that answer was. And you already know this if you looked at this. So you can see that they went ahead and by the numbers they rounded to 0.28.6 comes to 1 coil per line and 0.5 paper clips per line. Let's count 0.5 paper clips per line. Are you ready? So there's 0.51, 0.52, 0.53, 0.54, 0.5, 5.5, 6.5, 7, 7.5, 8, 8.5, 9, 9.5, 10, 10.5, 11, so forth. So this is what I was trying to do just a bit ago writing, but you can see I ran out of space. And they got it all the way up to 14, 14.5, 15. So you didn't need all this, but it's all right. It's not a whole big waste of space. On the bottom, we had by ones, if you recall, we had one coil per line. That's what that slash means, per. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You don't always have to write every number. Otherwise, you get a whole bunch of numbers and get really messy and all cluttered in there. And so now you plot your points. So that's the next thing. Number and label each axis and title the graph. Well, I did forget title and graph, but I would do titling the graph first. This one tells you to do it so long as you title it at some point, first or last. So what is the average number of paper clips versus number of coils? That's a descriptive, tells everyone what it is you are looking at, right? So you look at your first one, your data, and it's probably best to rewrite this. And when you rewrite it, you'd write 5 and 4, 10 and 7, 15, 11, 20 and 14. And let's see, here's where they have it. Determine the data points, 5 and 4, 10 and 7, 15, 11, 20 and 14. So for the first data point, 5 and 4, we come down, we go over to the 5 and we count up to 4 and we plot our point. Now again, this is not graph paper, so if you can use a ruler or any straight edge to get as straight of a line as you can, where the 5 and the 4 is called an intersection where they come together, and that's where you plot your point. And then 10 and 7, so I'm going to go over to the 10 and count up 7, and with the ruler again, I could probably put it right there, draw one line, and 7, draw the other line, my second point. Once I've gone through all my data points, as I've rewritten them, like I said, doing a graph is a lot more work, but you're doing this so you don't have to explain it with 1,000 words to every person. You can show them this picture and they know exactly what happened. So you should be able to summarize your graph in one sentence. What would summarize this one? Well, we can truly see that this line is going up at a slant, that slope. So a concluding sentence would be something like, as the number of coils increases, the more paper clips you can pick up. There you go. That's a conclusion anyone can see just from looking at this graph. Now, the best fit line, you don't have to connect the dots. As a matter of fact, you should never connect the dots in this sense. What you want is a best fit line. And best fit line simply goes from that point of origin and it runs through that last dot. And you see how far off. So this dot right here is not too far from the line, and that's fine. This one's right on the line. This one's also not too far. So this is a pretty nice, what you would call precise measurements, right? And they're accurate. Anyway, nice clean slope. So when you come to this one, graphing, now we can count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if there's 10 here, there's halfway through, there's 10 here, that's going to be 20 going across our x-axis. So I want to jump to what we usually see as the hardest part. So which of these two is our dependent or independent variable? Think about it. Take a guess. All right. So the year is going to be the independent variable. That's when we're choosing to measure Mr. Gooch's weight. And the weight depends on the year. So this over here is going to be the dependent variable. So do you remember dry mix? DRY, D is dependent, Y, dry. So that's the y-axis. So let's go with the year first. We have 2014 and 2005, the difference there. And then for Mr. Gooch's weight, on the dependent variable, smallest value is 93, the largest value is 112. And so that tells you, because remember, we don't have to start at 0. right? And now you count 20, divide by 20. So in the end, this is what it's going to look like. 05, we can start off up to 15. We did this by every other. And you can pause this if you'd like to check your answer. Now, right here, this is actually an example I forgot to use in class that shows what not to do. So this is fine. This would be, if you came up with this, you would be correct technically, but by convention, look at all this waste of space here. What is all this telling us? Nothing, right? It's not saying anything. So that's why I'm saying we could just start off with not 0, but we can go right down to the number. So lowest value was 93. 90 would be a good one. And if we put it at 90, we would be about right here. And that would really stretch this out nice and pretty. We'd really get a good idea. Whoops. I'm going to do that. Idea of the trend that you're looking for here. All right. So now that you have this picture on this video with these instructions and this data, you can now go back with the same data and looking at the scale. The directions for how to do the scale are right here. You get your lowest and your highest values and you get the difference. Then divide by the number of spaces. So get your lowest and your highest value, 93 to 112, and you get the difference. Count the squares and divide by the number of squares, and that's the values you would place there. Right. If I did one, let me see if I can finish with this. So we have this one, let me move it. 112 minus 93. Quick to the math, that's going to be 103, 113, 20. So we're going to round up to about 20. And you can do that. That's fine. You're just guesstimating. That's 20. And let's see how many lines were in our square. 20. I believe we counted here. There's 10 up to there and 10 up to there. So that's going to make it nice and easy, right? So if the difference is about 20 and you have 20 squares, then what value are each of these squares going to have? You can do this. That's right. You're going to have about, let me clear this. 1, right? Because 20 divided by 20 is 1. So each of these will be 1. Now you're not going to have a value, right, on every single one. Go back to your data. The entire kind of switch in. It takes a little time every time I switch back and forth. So you're going to start at 93 and work your way up to 112. So you can start at 93 right here. And work your way up to 112. 93, 94, 95, 96, 97, 98, 99, 100, 101, 102. And I'm going to have to scroll again. Sorry, this program is just not conducive to that. Anyway, and you'll get your 20. Okay. I hope that helps and clear it up more than I muddled it up. But remember, I have Zoom hours between 2 and 3 every day. And Friday, 10 to 12, and 1 to 3. If you have questions on this, tune in.